Hi, this is Kevin Trainer. Welcome to my lecture on Chapter 15 of Interaction Design 4th edition. Chapter 15 is called Evaluation, Inspections, Analytics, and Models. And Chapter 15 is the last of the chapters in the book. So this is going to be the last of the lectures in this series. So let's get started. So what are the aims here? We want to describe the key concepts associated with inspection methods, explain how to do heuristic evaluation in walkthroughs, explain the role of analytics in evaluation, and describe how to use Fitts' law, which is a predictive model. A very popular one. Okay, so I just want to point out that this is a part of user-centered interaction design where we're not directly interacting with users, right? And that's probably why we're talking about it last. Okay. Yeah, users are involved, but they're not primarily. They're not committed, I guess I would say, to go back to an old agile development joke, which I will not share with you. I'll spare you that. Okay, so in these inspections, we have some activity going on that is different from the kinds of user testing and data gathering and all that stuff that we've been doing in the last series of chapters. So there are several kinds of inspections. In these, experts use their knowledge of users and technology to review software usability. So instead of showing our product to actual users and gathering data about how they interact with it, we're going to show our product to experts, have them interact with it, and then get some kind of feedback from them. The kind of critique we can get from an expert could be either formal or informal. And one of the kinds of inspections an expert critiques is called heuristic evaluation. It's a guide, it's a review that's guided by a set of heuristics. Another approach is called walkthroughs. So walkthroughs involve stepping through a pre-planned scenario, noting potential problems. And walkthroughs, although it's not clear from the bullet points here, walkthroughs are a little more fine-grained than heuristic evaluation generally, and would be a way to get a larger quantity of feedback about perhaps a smaller part of your application. Heuristic evaluation hasn't been around forever. The approach, the formal approach, was developed by Nielsen in the 1990s. It's based on heuristics distilled from empirical analysis of 249 usability problems. So instead of just having these be kind of good ideas from experience, okay, Nielsen took a more research-focused approach and tried to enumerate all the usability problems and then to distill out of them these heuristics. Now, when these were done by Nielsen in the 1990s, most applications were done on desktop PCs. Okay, so the heuristics that he developed are really geared towards those. So people have been revising those in order to come up with a set of heuristics that's appropriate for things like mobile devices, especially smartphones, wearables, virtual worlds, all those kinds of things. And there's a good discussion in the text about the close relationship between design guidelines and heuristics, right? Because they're really kind of two sides of the same coin, right? Where do we get our design guidelines? Well, we didn't just get our design guidelines from, kind of reading and thinking. A lot of our design guidelines came from research, right? Well, where did these heuristics come from? Well, they came from research as well. Research is kind of similar to the research that Nielsen did to extract these heuristics. So it's not surprising that when you see the heuristic rules and you compare them to design guidelines, either ones that we've talked about in the course or design guidelines that you remember from your practical experience, there seems to be a pretty close correlation. And that's really not accidental. So they're not the same things, but they're very closely related. Here's a revised version, revised in the year 2014, of Nielsen's original list of heuristics. So here are the things that we want to be done well: visibility of system status, a match between the system and the real world, user control and freedom, consistency and standards, error prevention, so prevent errors rather than complain to the user that they made errors, recognition rather than recall. So there shouldn't be a lot of short-term memory load. Whatever we can avoid to keep down the memory load, we want to do that. Flexibility and efficiency of use, aesthetic and minimalist design. We want to help users recognize, diagnose, and recover from errors, and we want appropriate help and documentation. So these are the heuristic categories under which we could have an expert do a heuristic analysis of our user interface. So then the question is, all right, this is the same kind of problem that we had with the number of users. When we were doing user testing with either current users or prospective users, we had this question of, well, how many users do we need? How much testing do we have to do? And we came up with the idea of, 5 to 9, and, you better have 5, right? Well, interestingly enough, Nielsen and other researchers did some research on this, on how many evaluators do you need in order to find a large proportion of your problems. And as you can see from the graph that we see here, at about 5 evaluators, we've got about 75% of the problems found. And it doesn't increase that fast after that. So there's been talk about the 5-ish kind of rule applying to this as well. So here, to repeat myself, Nielsen suggests that on average 5 evaluators will identify 75 to 80% of usability problems. And some other researchers, Cockton and Woolrych, point out the number of users needed to find 75 to 80% of usability problems depends on the context and the nature of the problems. And there's a real good discussion in the chapter of some of the research indicating that when you have these heuristic evaluations by experts, you may be finding a different kind of problem that than what you're likely to find with user testings with real users, right? So none of these things are perfect. We don't always find the same thing. But one of the aspects of having an expert do something is, of course, by their very nature, experts are biased, right? They have all this experience and they believe it's important, and they have the beliefs that they have, and so they're telling us how users are likely to react. And of course, all that's based upon this accumulated wisdom that went into the heuristics and has gone into the design guidelines and all that kind of stuff. It's all important stuff, but of course, it's not real experience with our users, is it? Now, there's another side to that, though, in that, let's say we have a completely new application, right? Well, as a result, every user that we give it to is going to be a novice, right? By definition, right? And our user testing is only going to run for so long. So at best, by the time they get done, they might be an intermediate, okay? But they're probably still a novice, right? One of the things that that I think the expert evaluators are more likely to find than our actual users used in user testing, are kind of common garden users. The experts are more likely, I think, to find some of these things are going to be problems for intermediates and experts. And probably if you want to know what the novices are going to have a hard time with, you probably are going to get the most information by showing it to a bunch of novices and see what their sensibilities are, right? Some work has been done to take the heuristics that were developed by Nielsen in the early 90s and bring them forward to the 21st century. And in particular, a lot of work has been done by two different groups. One, which is the subject of the slide here, Bud, work done in 2007, on heuristics for websites. And we talk about clarity, minimizing unnecessary complexity and cognitive load, providing users with context, promoting a positive and pleasurable user experience. And this isn't a discussion that's in the text, but this is a distinction that I want to point out, is that there's a real difference between the usability of online transaction processing applications, situations where people are using the computer to do data processing, and websites where people go to find information in order to solve their problems or to entertain themselves. So that this website focus, I think, is loaded more heavily towards the latter. We had there's a pretty good discussion in the text of things like how likely are people to want to come back? How likely are people to, what's their expectation that they're going to get novel information in a pleasurable way the next time that they come back? Which is not really the questions with a lot of online transaction processing systems. of course, we want people to come back, but it's a different kind of focus. Sometimes in online transaction processing systems, there's only one way to do this thing. The only way to do it is to use our application. So maybe people will say our application is so frustrating they don't want to be our business partners anymore. Okay. Instead of, if we have some information site, perhaps they'll come a little bit less frequently to visit our information site if it's boring or frustrating or hard to navigate. But so there's a parallelism to true kind of hands-on data processing application and information site web applications. But I think that these criteria that we're seeing here developed by Bud are kind of getting at what are some of the differences in the experiences that users are having on the web. And so the criteria are going to be slightly different. There's a discussion in the text about two heuristic evaluations that were done with these ambient displays. And these ambient displays, one was to give information about how close our bus was, and the other one was to get information, that's the one on the left, and the other was to give information about whether it was light out or dark. And in each case, these things try to, there was some kind of a metaphorical connection between what was happening with the device that we were seeing and some kind of state of affairs in the world. So there's a nice discussion of both of those in the text. So if you're going to do heuristic evaluation, there are three stages in which you would want to concern yourself with. Now this is already past what kind of experts am I going to use and how many experts do I need, right? And we already said, well, 5-ish, okay? So we get the experts and we need to have some kind of a briefing session to tell the experts what to do. And then we would expect to give the experts some time to work on their own, in which each of the experts works separately in this kind of 1 to 2 hour session. They take one pass to get a feel for the product, kind of just using their own instincts, and then they take a second pass to focus on specific features that we have asked them to evaluate, right? So they all work separately. One pass kind of just using their instincts, and then the second pass following some kind of scripted scenario whereby they visit the features that we want them to visit, perhaps in a particular order, but in any case, we want to make sure that they do the things that we want them to do. And then the third part is a debriefing session in which the experts work together to prioritize the problems. So this is another, I think, kind of interesting design where we have multiple people producing their point of view, and we are going to try to reconcile them, but only after they've had the opportunity to have independent experiences and done some recording of those, so that they don't sort of poison each other's or bias each other's experience. So what are the advantages and problems of this heuristic evaluation approach? Well, from ethical and practical issues, from that point of view, it's easier because, particularly from the ethical side, we don't have such a problem with informed consent. We can assume that whoever these experts are, that we're employing them, we have some kind of a professional or contractual relationship with them, and the kinds of ethical concerns that we have with more typical research subjects are not as important. Of course, we don't want to kill anybody. We don't want to publish their image in places where it's not supposed to be published. I mean, we could do some bad ethical things, right? But they're not, the challenges are certainly not so great. It can be difficult and expensive to find experts. If we're really looking for people who are interaction design experts, and ideally I think we'd want people who had some expertise in our kind of device at a minimum, if not our application as well. Well, they're not all over the place, okay? So the best experts have they know the application domain, so they know what we're trying to build, and they also know users. So they'd be both interaction design people and who would know the application as well. Our biggest problems? Well, we might miss some important problems. Many trivial problems are often identified. Again, the more expert a person is, the more biased they are. I mean, it's really the same thing. They're opinionated people. We hope they're they're even-handedly opinionated, but of course, they may just have some pet peeves. And what we're likely to see is, if we hire 5 independent experts, well, we're going to get we're sure to get all their pet peeves taken care of. Okay, so the question is, are these certainly we want to listen to their pet peeves, and certainly we want to listen to the big things that they found. But are there other things that would be important to a more realistic sample of users, non-expert users, that we're missing? Another approach, kind of like this heuristic evaluation, but different, is called cognitive walkthrough. Okay, and typically we're trying to focus on the ease of learning of our application. The designer presents an aspect of the design and usage scenarios. An expert is told the assumption about the user population, the context of use, details about the task to be done. One or more experts walk through the designed prototype with a scenario, and the experts are guided by 3 questions in a cognitive walkthrough. Will the correct action required of the user be sufficiently evident to the user? 2, will the user notice that the correct action is available? And then 3, will the user associate and interpret the response from the action correctly? As the experts work through the scenario, they note the problems. So this is pretty detailed stuff, okay? We're trying to really get at, typically we would want to apply this this kind of a walkthrough to difficult parts of the application, right? Maybe highly technical or highly things that have a big load in terms of we want to make sure that the users understand the mental model behind our design, and they're really following along. This is probably going to be applied to smaller portions of the overall application, and it's going to be a little more intensive, and it's going to throw off more detail about this kind of smaller portion of the application. There's another kind of a walkthrough that people do. They call a pluralistic walkthrough, which is a variation on the cognitive walkthrough theme. It's performed by a team again. It's a panel of experts that begins by working separately. Then there is a managed discussion that leads to agreed decision. So this is an approach that works well with participatory design. And there are all kinds of kind of adaptations like this pluralistic walkthrough that we can do with this approach to cognitive walkthrough. Or if we're not going to be doing the heuristic evaluations, and we're not going to be doing something from that family of walkthroughs that we're talking about, perhaps we're going to use analytics. Okay, so mostly when people are talking about analytics, they're talking about web applications, and they're talking about web analytics. And the two web analytics platforms that are discussed, I think, reasonably well in the book are Google Analytics and Visistat Analytics. And the idea of these things is to analyze the pattern of clicks that goes on between a population of actual users in our actual application. And one of the reasons that this is such a I'd say a fertile opportunity for analysis is that because of the architecture of web applications, okay, for good or for bad, in most applications, we have a pretty long and detailed click stream that goes on, conducted by the user on the client, and it's sent over and over and over again to the server. And so any kind of analytics that are distilling the data of which HTTP requests are being sent to the server, they're operating on real data. And this is really a richness of data out there that you wouldn't typically have with let's say a dedicated desktop application written in, say, C++ or something like that. Sure, there is a conversation that goes on between, let's say that was a client-server application, and there was a web services backend. Well, you could go look at the conversation between the client and the web services application, but you're not getting quite the detail that you're going to get with a pure kind of a web application, where just every click in the user interface, almost every click in the user interface corresponds to a request that gets sent to the server. So it's a rich opportunity. So to the extent that we're moving to, say, mobile apps, and to the extent that we're having richer web apps where there are fewer requests that are going to the server, well, then that's just less information about the interaction that we can get from web analytics. So I think they give you a pretty good idea of what you can get from web analytics here. Figure 15.5, you can see what the traffic was according to hours of the day on a particular date. You can also go down and see what the traffic is within a particular time frame by geography, so you can see where the traffic is coming from. There's another kind of analysis that's done that's a network analysis. This is from work that was done by Schneiderman back in 2008. This is a social network analysis showing clusters and relationships between the entities and the clusters. So how did they do that? Well, they mined available data. Now, the typical thing that you see people doing with this is trying to see which kinds of social interactions people are having on social media apps. So it's less the question of what the minute by minute experience is, and more the question is what's the day-to-day and hour-to-hour experience in terms of who's communicating with whom and talking about what, right? And how can you do that? Well, for instance, you can go to a platform like Twitter, and you can use the Twitter API, and you can through their web services, you can request a bunch of data, and then you can bring it down and run analytics on it. Now, whether that's going to help you make decisions about the user interface or more the functional requirements for the system, or perhaps even the non-functional requirements apart from the user interface, it's still cool stuff, and it is a data analytics kind of a deal. The last thing that we're going to be talking about here are what we call predictive models. They're a way of evaluating products or designs without directly involving users. They're less expensive than user testing, and their usefulness is limited to systems with predictable tasks. Telephone answering systems, mobile applications, smartphones, those kinds of things. And they're based upon expert error-free behavior. And the classic predictive model is Fitts' law. So Fitts' law predicts that the time to point to an object using a device is a function of the distance from the target object and the object's size. So the farther away and the smaller the object, the longer the time to locate it and point to it. So the closer and the bigger, the faster it is to locate it and to point to it. And you just have to think about that for a minute, and you go, that's true. That meets up with my experience as a user. So Fitts' law is useful for evaluating systems for which the time to locate an object is important. cell phones and smartphones, other handheld and mobile devices. And really, and there's a good comment on this in the text, things that have to do with, say, safety, right? So, for instance, I used to have this really cool woodworking machine that was a computer controlled router. And it was a pretty powerful thing. And one of the questions that I had was, how hard was it to find and hit the emergency stop button? And there were two versions of the emergency stop button. There was one that was on the application that ran the router, and there was another one on the physical controller. There's a big red mechanical button. And typically, when the router was going on, the big red mechanical button was closer and bigger than the little red stop button that was available by mouse that was on my PC on the other side of the physical controller. So that's a case where it's really a safety kind of issue. And, we have a lot of those kinds of situations where sometimes it's not safety but quality. But we have all kinds of devices that are controlled by information systems these days, in which the ability to get to one of the controls and to manipulate it quickly is either going to have a big impact on safety, or a big impact on quality, or both. So just a bit of a review for the chapter. What we're talking about in the chapter are inspections. They're an alternative to testing with real or prospective users. They can be used to evaluate requirements, mock-ups, functional prototypes, or the systems themselves after they've already been built. It's important for us to know that user testing, like we did in previous chapters, and heuristic evaluation may reveal different usability problems. Okay, in my guess, although I don't have the research to point to for this, but in my mind, heuristic evaluation by experts will probably do a better job of finding the kind of problems that are going to be problems for our intermediates and experts. And user testing is probably going to do a better job of finding the problems that are going to happen to our novices, because by definition, in most cases, the users that we're turning loose on our new system are novices, because the system is new. So they have to be new to it. Design guidelines can be used to develop heuristics. Okay, so design guidelines and heuristics are kind of two sides of the same coin. Hopefully they're not just hopefully they're not simply folk tales about interaction design, but they're based upon either practical experience, as anecdotal as it might be, and on research as well. Walkthroughs are suitable for evaluating small parts of a product. So one kind of a differentiator between these heuristic evaluations and these, say, cognitive walkthroughs is that the cognitive walkthroughs are more focused on smaller parts of your application, probably ones that have a pretty big cognitive load. Okay. We talked about analytics. So analytics involves collecting data about users' activities on a website or a product. And as I indicated, the more our website or product is a plain old HTTP application where every click on the page generates a request to the server, well, the more data that we have to analyze. And the more that we have things like either mobile apps that are controlling the user interface in the app and only communicating with the backend for data, or the more we're doing that in the browser with approaches like Ajax, well, the less data we generate, that's going to help us with the question of what's it like to interact with our product. But still, it's pretty well free data. So whatever we have, it's something that we ought to want to take a look at. And lastly, we were talking about predictive evaluations. It can be done with things like Fitts law, where we can just from being able to look at the product or the design for a product that isn't even a product yet, we should be able to predict, for instance, according to Fitts law, how long it should take a user to be able to find our control, whatever it is, and trigger it. Okay? And typically, the closer it is to where they are now, and the bigger it is, the shorter the time will be. Or the corollary, the farther away it is, and or the smaller it is, the longer it will take. So that's it. I've enjoyed this opportunity to share this textbook with you. I'm just going to say goodbye until next course. Bye-bye.